This supplemental video provides a demonstration of the AortaAnalyzer, a platform for interactive, integrated CTA aorta segmentation and quantitative analysis. The data cases in the working directory are displayed on the left, together with an overview of the available files of each case. To work with the data case, the CTA data has to be loaded into the framework. The data processing begins in the segmentation module. To diagnose aortic diseases, physicians use CTA scans to evaluate morphology and measure vessel diameter. To extract a 3D representation of the aorta, the vessel has to be segmented. To avoid this time-consuming process, a neural network is incorporated to generate a prediction of the segmentation mask. The progress of the prediction is documented in the progress bar below. With CUDA acceleration, this process takes only about a second, and without availability about 14 seconds. Once a new label mask is available, the automatically generated surface is displayed in conjunction with the volume. Saving the changes will automatically update the data in the subsequent modules of the pipeline. Additionally, the new data will be reported in the data inspector. If the prediction should not be satisfactory, the editing mode can be used to correct errors by clicking on the slice view. A brush and eraser are provided to assign pixels to the vessel or background. Each can be used as a 2D version for precise editing of individual slices and a 3D version for quick segmentation of larger areas. A Hounsfield unit threshold is available to further accelerate the correction. To determine the internal radius of the vessel and to get a topological representation, the centerline computation of the vascular modeling toolkit is integrated into the framework. The calculation requires the user to specify the approximate start points at the aortic root and the approximate endpoints of the centerline at the end of the branches. Branches of interest and branches to be omitted can be specified this way. For easier selection of the source and target points, the opacity of the surface can be altered. The calculation of the centerline is carried out in the background and then displayed so that the user can check the results. Together with the previously generated surface, the aorta can now be analyzed in the metrics module, further processed for computational fluid dynamics in the capping module, or additional functions could be integrated into the framework to utilize the data. In clinical practice, the maximum diameter is the most important factor in assessing the risk of rupture of an aortic aneurysm and the progression of aortic disease. Using the centerline, the maximum diameter is automatically determined and displayed in the diameter overview. Additionally, the diameter can be normalized by the patient's height. To get a more expressive assessment of the vessel morphology compared to the diameter alone, we include measuring volume and surface in a customizable region. By positioning the two markers on the surface, the boundaries of the measurement area can be set. In case of branching vessels, the user can decide whether to include or exclude them. When all boundaries are confirmed, the specified area is extracted, measured, and the parameters are displayed once again in the overview on the right. Measurements can also be captured at different landmarks. To set a landmark, the slider has to be moved to the desired position by clicking, scrolling, or dragging, and the according landmark has to be selected in the drop-down menu. Once set, the diameter is displayed in the color-coded overview. In addition to the predefined landmarks, up to 4 custom landmarks can be defined. For surface capping, in preparation for blood flow simulation, capping sites are automatically generated according to the centerline's start and end points. The recommended sites can also be manipulated, removed, or new added if necessary. After capping, the original surface is overlaid to allow better assessment of the results. When the clipped surfaces, caps, and the cut centerline are saved, the file format can be selected.